Everybody. In this video, we're gonna try to put these two formulas right here. Returning cos to the power n to go from 0 to pi over 2 x. So in this video, we're gonna try to prove this one first, and then in a subsequent video, we're gonna prove the second one. In a previous video, we proved that the integral of cos to the power n of x dx is equal to this. So we're gonna use this result to prove that integral from 0 to pi over 2 cos to the power n of x dx equals to equal to root third times 4/5 times 6/7 times 11. It's n cube part n greater than right. So as we say, we're gonna use this formula right here. So we have integral of 0 to cosine pi over 2 plus the power n x dx is equal to plus to the power n minus 1 of x sine over n 0 pi over 2 plus n minus 1 over integral from 0 to pi over 2 of course the power n minus 2 of x dx. So the reason why we're using this square bracket is because this integral is defined. That is a definite integral, which is not the case in this one, which is just indefinite, so we don't have to put brackets, but we don't have bounds. But on this one, we need to use this this scripture. Okay, so we have integral from 0 to pi over 2 plus the power n x dx is equal to 0 because all this is 0. If you put pi over 2 as an argument for cosine, is 0. And if you put 0 for sine, it's going to be 0 as well. Sine of 0 is 0. So the difference between two zeros is 0 plus n minus 1 over n of the integral from 0 to pi over 2 plus to the power n minus 2 of x dx. It means that the integral from 0 to pi over 2 plus to the power n of x dx is equal to n minus 1 over n times integral from 0 to pi over 2 plus to the power n minus 2 of x dx. From here, we're gonna define a sequence En equals interval from 0 to pi over 2 plus the power n of x dx. So this means that this formula right here, in terms of u, would be u of n equals n minus 1 over n times. So cos to the power n minus 2. If we place here n by n minus 2, it would be u minus 2, n minus 2, u n minus 2, which is the same thing as un over un minus 2 equals n minus 1 over n. So we define the sequence un such as un is equal to 0 from 0 to pi over 2 of cosine to the power n of x Yes. And we had found that un over un minus 2 equals to n minus 1 over n. Now, if n is odd, n greater than 3, you're gonna have u3 over 2 3 minus 2 equals 3 minus 1 over same thing as u5. So n is odd, so we're only gonna use the odd values of n 3, 5, 7, etc. So u5 over u5 minus 2 equals to 5 minus 1 over 5, etc. So we'll have un minus 1 over un. So it map right un over un minus 2 equals to n minus 1 over n. So we only consider the odd values of n starting from 3. You like u3, u5, and n being odd. So multiplying all these together gives us like u3 over 3 minus 2 is 1. So u1 times u5 over u5 minus 2 is u5 over u3 times etc. times un over n minus 2 equals n minus 1 over n times etc. times 5 minus 1 over 5 is 4 sixths and 3 minus 2 minus 1 is 2 thirds. So we have that un u3 over u1 times u5 over u3 times un over un minus 2 is equal to 2 thirds 4 fifths times n minus 1 over n. For n odd and n greater or equal to 3. Alright. Now from here we see that some term simplifies together, like u3 and u3. Something it would if you kept putting those terms, you would have u5 and some u5 as a denominator, which will cancel with this one. Something for un minus 2, there will be a un minus 1 here. So at the end, we'll be left with un over u1 is equal to 2 thirds minus 4 fifths times etc. n minus 1 over n, which is the same thing as un equals u1 times 2 thirds times 4 fifths times n minus 1 over n. So we need to find the value of un. Just remember that un is equal to your 5 over 2 plus n. Yes, this means that u1 equals the integral from 0 to pi over 2 cosine x is just power 1, so it's cosine x, which is equal to sine of x to 0 to pi over 2, which is 1. So we have n is 1, which means that u1 is just 1, which means that un is equal to 2 thirds times 4 fifths times 6/7 times n minus 1 of n. Since un is the same thing as integral from 0 to pi over 2 cos to the power n of x dx, you can say that integral from 0 to pi over 2 of cos to the power n of x dx is equal to 2/3 times 4/5 times 6/7 times n minus 1 over n, n greater or equal to 3, then forward. Alright, thank you for watching. See you on next video for the second part, where n, I'm gonna prove the formula for n even and n greater or equal to 2.